In 1951, the US Air Force decided to replace all of its piston-engine transport aircraft with a new family of turboprop machines. Existing machines, such as the Curtiss C-46 and the C-119 flying boxcar, had a limited load carrying capacity and needed a considerable length of concrete runway in order to operate effectively. The General Operating Requirement, issued in February 1951, called for a four-engined aircraft capable of carrying out several different kinds of mission. As a troop carrier, it should have an operational radius of 1,100 nautical miles and be large enough to accommodate 92 infantrymen or 64 fully laden paratroopers. In the resupply role, it was required to carry almost 17 tons of freight over 950 nautical miles and be able to return to base without refueling. Finally, in order to be effective in any likely combat zone, it would need a short takeoff and landing run and the ability to operate from rough or unprepared airstrips. Several American aircraft manufacturers were invited to submit proposals. They included Boeing, Fairchild, Douglas, and Lockheed. Although the other three companies all had more experience in building large transport aircraft, Lockheed decided to forward a design which would greatly exceed the operating requirements. Based in Burbank, California, the design team led by Willis Hawkins opted for a high wing layout and a wide-body fuselage with a huge built-in loading ramp sited at the rear. The main load compartment, measuring 10 feet wide, 9 feet high and 40 feet long, would allow bulky items of freight to be carried with ease. Power would be supplied by four Allison T-56 turboprop engines, each developing 3,700 horsepower. Coupled with three-blade variable pitch propellers, the engines would give the aircraft a fast rate of climb and a cruising speed of 360 miles an hour. Lockheed's proposal, designated the C-130, was submitted to the Air Force in April 1951. Within 2 short months, it had been chosen as the winning design, and shortly afterwards the company was awarded a contract to build 2 prototype YC-130s. Work began at the Burbank plant, and in September 1952, orders were placed for the first production batch of 20 C-130s. While the prototypes were being completed, plans were laid for full-scale production to take place at the Marietta factory in Georgia. The first prototype was rolled out in the summer of 1954, and on the 23rd of August, it made its maiden flight from Burbank at the hands of Stanley Belts. It far exceeded the requirements in every respect. The cruising speed was higher, and the climb rate was faster than the original Air Force specification. In spite of having a payload of more than 17 tons, the aircraft weighed less than the requirements had stated and could take off and land in distances that were way below the specified limits. Wingspan was 132 feet 7 inches, and overall length was just under 100 feet. The main undercarriage layout, consisting of 2 pairs of wide wheels arranged in tandem, reduced the risk of sinkage when operating on soft or unprepared surfaces. Using the nose wheel steering gear, the aircraft could turn itself round in less than 50 meters. Reversing propellers gave it the ability to taxi backwards, and in confined spaces, to carry out a 3-point turn. From a pilot's point of view, the C-130 was easy to handle and had ample room for a crew of 5. The cockpit windows provided excellent all-round visibility, a feature which was vital for assault or supply missions in difficult terrain. To facilitate the task of loading freight, the upward hinged cargo ramp could be opened to the same height and level as a standard American truck bed. With the ramp closed and the internal door shut, the fuselage could be fully pressurized. This would enable the aircraft to fly at any altitude up to its service ceiling, even when carrying troops in the main compartment. Inside, the seating layout for troop transport could be easily rearranged to suit the number of men involved. And in the casualty evacuation role, there was enough room for up to 74 stretchers. The 2 prototypes were soon followed by 6 development aircraft, all of which constructed at the giant Marietta plant. first of these made its maiden flight in April 1955 and caused an immediate sensation. Onlookers were astounded to see such a large aeroplane take off in only 800 feet and climb away so rapidly that it had reached more than 2,000 feet before it crossed the end of the runway. By the end of the following year, the remaining 5 production machines had all been completed. Designated as JC-130As, they formed the basis of the lengthy C-130 test program. The only major problem to be encountered with the aircraft lay in the unstable performance of the electrically controlled propellers. The situation was temporarily resolved in 1955, when the triple-blade Curtiss units were replaced by hydraulically controlled propellers manufactured by the Aero Products Company. Eventually, all Hercules variants from the B model onwards would be fitted with 4-blade Hamilton Standard units. By 1956, more orders had been added to the initial batch of 20 production machines, and by the beginning of December, the Hercules C-130A had begun to enter regular service with the U.S. Air Force Tactical Air Command. The first 40 aircraft went to the 463rd Troop Carrier Wing, situated at Ardmore Air Force Base in Oklahoma. A few months later, another 50 machines were delivered to the 314th Troop Carrier Wing at Stewart Air Force Base in Tennessee. By 1958, Tactical Air Command had more than 150 C-130As in full operational use. And in addition to the American-based units, some squadrons were based in Japan and others in France. Lockheed had already announced their intention to develop and produce new variants. The 130B soon appeared and made its maiden flight in November, equipped with the new Allison 4,050 horsepower engines and 4-blade Hamilton propellers. With increased power and an extra fuel capacity of 1,800 gallons, the new model had a longer range and a higher takeoff weight than the C-130A. "123 machines were built for Tactical Air Command, and another 40 were destined for Lockheed's export customers. KC-130B tanker and LC-130B transport versions went to the US Marines and the US Navy, while the US Coast Guard took delivery of the HC-130B rescue variant. Another batch of Bs were converted for use as satellite recovery aircraft. Fitted with a retractable trapeze system to catch the satellite's parachutes in mid-air, they were used in the Pacific during the Discoverer satellite program. Meanwhile, for operating in the extreme conditions of the Arctic and Antarctic, some A-model aircraft have been fitted with skis. This variant became the C-130D, and with its main skis measuring 20 feet by 6 feet, it was the largest ski-mounted aeroplane ever built. A number of machines were used to transport the enormous quantities of materials needed for the construction of America's Arctic line of early warning radar stations in Greenland. In 1961, the third production variant of the transport series began to appear in numbers. This was the C-130E. Adopted by the US Air Force for both tactical and strategic operations, it became one of the most successful and most widely used of all Hercules variants. Once again, fuel capacity was increased to give the aircraft an even greater range than its predecessors. With a dramatic increase in payload, the E model had a maximum takeoff weight of almost 80 tons. It could carry 16 tons of cargo for more than 3,000 miles without stopping to refuel. More than twice as many E's were built than all the previous variants added together. Of almost 500 aircraft completed by Lockheed, 4/5 of them were delivered to the American Armed Forces, while the remainder were exported to a number of other countries, including Australia, Canada, Saudi Arabia, and Sweden. A whole range of conversions and subvariants grew out of the basic C-130E. NASA used the C-130 to test the Mercury capsule, which was used for America's first manned spaceflight. The capsule was taken up and dropped a number of times. With the rear door of the C-130 open, the capsule slides out on a slab. The slab then releases, and a small charge ejects a drawn parachute. This was for high-altitude parachute tests and the search and recovery systems once the capsule had landed. The C-130 Earth Science Platform has been performing Earth resource investigations since 1969, when it was put to use by NASA Johnson Space Center. Ames Research Center acquired the aircraft from Johnson in late 1981 and has made extensive modifications in order to support its current project requirements. The investigations performed on the aircraft cover a wide spectrum of scientific studies within the broad area of Earth resource data acquisition. Experiments in agriculture, meteorology, zoology, and instrument simulation are all studies supported by the C-130. The primary mission of the C-130 aircraft platform is to develop the sensors and techniques for remote sensing of crops, non-renewable resources, and for soil geological mapping. In some of its earlier investigations, the C-130 supported international ocean Atlantic programs and played a major role in the 5-year program of soil moisture experiments. In addition, the aircraft's sophisticated mapping capabilities were utilized in underflights to help calibrate land satellites. These capabilities are made possible by a piece of equipment available only on the C-130 and the U-2ER-2 aircraft. The MS-001 Thematic Mapper Simulator has 8 channels covering the visible and infrared spectrum. 2 video and 2 still cameras are mounted in the aircraft as part of the investigation equipment. The 2 still mapping cameras can use either regular or color infrared film. The C-130 contributes on an ongoing basis to scientific studies of the world. Naval versions of the B and E models were designated 130F and 130G. The most dramatic feat the Navy has asked of the Herc has to be landing on a carrier. These tests were conducted as a result of the Navy's realization that they needed a replacement for the range and payload limited C-1 Trader. The airplane they used was a KC-130F. The only modifications made were installation of an anti-skid braking system, smaller nose wheel orifice, and removal of the wing-mounted refueling pods. Pilot for the tests was Lieutenant James H. Flatley III. Co-pilot was Lieutenant Commander W. W. Stovall. Engineer was ADR-1 E. F. Brennan. And the safety pilot, who also checked Flatley out in the C-130, was Lockheed engineering test pilot Ted Limmer, Jr. The tests were made on October 30th, 1963. They included touch and goes, full-stop unarrested landings, and launches sans catapult. Weights were varied from a low of 85,000 pounds to a high of 121,000 pounds. At the lightweight, the KC-130F was stopped in just 270 feet and launched from that spot with the aid of 40 knots of relative wind over the deck. A total of 29 touch and goes and 21 full-stop landings and subsequent launches were made. The seas that day were relatively heavy, with swells up to 15 feet. Flatley's skill and airmanship that day earned him the DFC. The feasibility of using the C-130 for COD had been demonstrated, but the program went no further. Official reasons for dropping the idea were given as it's being too risky. A more likely reason is that the C-130 was just too big to be stored in the hangar or on the flight deck. But two of the most significant Hercules developments were the AC-130 gunship and the EC-130 command and control aircraft. As a result of the escalating situation in Vietnam, the first Hercules to be converted to a gunship was the A variant, which was flight tested during the summer of 1967. With a side-firing armament consisting of 4 M61 20mm rotary cannon, 2 7.62mm miniguns, and 2 40mm Bofors cannon, the AC-130A could attack ground forces with a devastating level of firepower. A powerful searchlight mounted in the rear of the fuselage enabled gunship crews to carry out search and destroy missions, even at night. On later aircraft, firepower detection equipment and defensive armor were all improved, and in Vietnam the Hercules gunship proved to be an outstanding success. To turn the basic transport aircraft into a full battlefield command and control center, the EC-130, the US Air Force developed a special 10-ton command capsule. Housing communications equipment and with seating accommodation for up to 16 personnel, the USC-15 capsule was designed to slide straight into the Hercules cargo hold with the minimum of fuss. In the heavy freight lifting role, the Hercules was fitted with the LAPES low-altitude parachute extraction system. Ideal for use in situations where landing would render the aircraft vulnerable, items as big as a light tank can be dropped during a low-level pass. The cargo is secured to a shock-absorbing pallet and hauled out of the hold by a system of drogue and main parachutes, which are trailing behind in the slipstream of the aircraft. During a series of trials conducted at the Parachute Test Center in California, a 23-ton load was dropped using the LAPE system. Equipped with another aerial delivery system known as MAFS, several C-130s were converted as firefighting aircraft and supplied to the US Forestry Service and the Air National Guard. The modular firefighting system can release 3,000 gallons of fire-retarding liquid in less than 10 seconds. In the mid-60s, Lockheed submitted the Hercules for certification as a commercial aircraft. The first civil version, the L-100, made its maiden flight on 20th of April 1964 and received its certificate in February 1965. In 1968, Lockheed produced a stretched version in the form of the Dash 20. From 1970 onwards, an even longer version was produced. Known as the Dash 30, 2 fuselage plugs increased the overall length by another 7 feet. In spite of the success of the original E model, great improvements in performance came with the introduction of the 4th military transport variant, the C-130H. Uprated Allison engines developing 4,500 horsepower each gave it more speed, a faster rate of climb, and a shorter takeoff distance. Carrying a maximum fuel load and 10 tons of cargo, its range was increased to more than 5,000 miles. As the penultimate Hercules, the 130H entered service during the 1970s and became the most widely produced of all variants, including the E model. Once again, it spawned the usual variety of sub-variants, including air ambulances and tankers, as well as communications and weather reconnaissance aircraft. The ambulances can handle up to 74 patients with 3 attendants.
Okay, wing, rudder, keep straight. 50 neutral, please.
A stretched version followed the standard length transport and went into production as a C-130H-30. With its fuselage extended by 15 feet, giving an overall length of 103 feet, the H-30 became known as the Super Hercules. Most of the Hercules variants, ranging from the A to the H, were put to very good use in Vietnam. With its ability to perform in a multitude of roles, the Hercules was one of the most versatile aircraft to see action during the war. As well as carrying out routine long-distance troop movements, it perfected aerial supply techniques for all kinds of terrain. KC-130 tanker versions were used for in-flight refueling of Air Force and Navy fixed-wing aircraft, and for the ever-increasing number of helicopters. In the combat role, both the A, E, and H model gunships played a major part in anti-guerrilla operations over South Vietnam. By flying low in a series of tight left-hand turns, the C-130s could pour a withering level of gunfire into any area suspected of containing guerrillas. They were also used against North Vietnamese supply routes and were responsible for 50% of the supplies destroyed on the Ho Chi Minh Trail. MC-130s were used to drop special troops engaged on intruder missions behind enemy lines. Equipped with the Fulton pickup system, they were also used to retrieve personnel and to rescue airmen who had been shot down in action. The Fulton system consisted of a special harness attached by line to a helium balloon and a pickup yoke fixed to the nose of the aircraft. After it dropped the harness to the man on the ground, the Hercules would make a second pass directly under the balloon. As the line caught in the yoke, the man would be lifted from the ground and winched up into the aircraft. It was a reasonably safe and highly successful system. After the American Armed Forces, the world's second largest user of the Hercules is the Royal Air Force. 66 aircraft were ordered during 1966, and the first machine entered operational service in August of the following year. Based on the C-130H, the RAF version was fitted with British-built radio, autopilot and navigation equipment, and was designated as the Hercules C Mark I. The RAF standard crew consisted of a pilot, co-pilot, navigator, flight engineer and loadmaster. In the early 70s, 5 of Britain's 6 Hercules squadrons were based at RAF Lyneham in Wiltshire, but nowadays the entire force of 60 aircraft is stationed there. During their first 10 years of service, the RAF's Hercules carried out large-scale troop movements in Anguilla, Malta, and Belize. They evacuated British nationals and servicemen from Aden, India, and Vietnam, and flew numerous relief missions to famine and disaster areas such as Pakistan, Southern Sudan, Turkey, and Nicaragua. In 1980, the engineering company Marshalls of Cambridge began converting 30 C Mark I aircraft to a new C Mark III specification. Based on Lockheed's stretched C-130H-30, the C-3 version is 15 feet longer than the C-1. With the volume of its cargo hold increased by 37%, the C-3 can carry one extra Land Rover or 26 more paratroopers.
When we first bought the Hercules, we bought the C Mark I, which is the standard length of Hercules, and we discovered that the aircraft would often bulk out with load before it actually got as much weight as we could carry on board. So we actually had half of our fleet lengthened, and we turned them into the C Mark III. The basic difference is that the C Mark III is about 180 inches, 15 feet longer. It's got a plug at the front of 100 inches and another plug at the rear of 80 inches, giving us that extra length. So the Mark III is capable of carrying a lot more load now than the Mark I is. But it does have other effects. The Mark I is a better aircraft for purely tactical use, for operating off rough strips and such like. So we've got a good balance in the fleet now, giving us a broad capability.
When Argentina invaded the Falklands in 1982, the first Hercules was on its way to Ascension Island in less than 24 hours. More of them followed, and during the first 3 weeks of the emergency, they delivered nearly 1,500 tons of supplies to Ascension. On the 15th of April, it was decided to convert the Hercules for air-to-air refueling, and within 15 days of starting work, the necessary equipment had been installed and fully flight tested. This in-flight refueling facility enabled the Hercules C-1Ps to supply both the task force at sea and the troops on the ground. In an AAR operation on June 18th, one aircraft established a world endurance record for the Hercules of 28 hours and 3 minutes. 4 more aircraft were modified as C-1K tankers, and after the recapture of Stanley, they supported the F-4 Phantoms, which were tasked with defending the islands. During the Gulf War in 1990 and 1991, the RAF's Hercules fleet carried out a phenomenal amount of work. They carried 50,000 tons of freight and flew a combined total of 12 million air miles. In doing so, they consumed 24 million gallons of fuel. As well as the task of moving personnel and equipment for the Tornado squadrons, the C-1s and C-3s were also responsible for transporting support units and armor brigades in preparation for the ground offensive. Since the Gulf War, Lynam's aircraft have carried out relief missions to the former Yugoslavia and support missions for UN aircraft in the no-fly zone over southern Iraq. In addition to its wealth of operational roles, the Hercules has been a regular performer on the international airshow circuit.
Is air conditioned. So they're driving along in creature comfort there on this sort of warm day. It's a very nice breeze out here today, though.
Capable of dropping 64 men in its standard configuration, it has long been the workhorse of parachute display teams in both Britain and America. The American Navy team, the Blue Angels, took delivery of their first Hercules in 1970. and the RAF's display team, the Falcons, have been using the aircraft for almost as long. With countless displays to perform every year, the C-130s have flown millions of miles in support of these two teams. Under development during the 90s is the very latest Hercules, the C-130J.
The legendary C-130 Hercules, the world's standard tactical multi-role transport, has been continuously modernized since it was created by Lockheed in the mid-1950s. Today, more than 2,100 C-130s have been sold worldwide. They have logged over 22 million flying hours while effectively carrying out a great variety of military, civil, and humanitarian missions.
In recent years, the Hercules has served with distinction in military action in Panama, the Gulf War, and in humanitarian operations in Bosnia, Somalia, and Rwanda. But age and demanding missions have taken their toll. Downtime and maintenance costs are increasing. Fleet availability is decreasing. Systems built with 1960s technology require considerable manpower and make the existing aircraft increasingly difficult and expensive to operate and maintain. Lockheed's response is the C-130J, the next generation Hercules. The C-130J, an affordable off-the-shelf buy that represents a balanced solution, offering high performance, yet reduced operating and support cost for its 30-year lifespan. From the exterior, the C-130J appears similar to the current model Hercules. But let us show you that under the skin, the C-130J is virtually a new aircraft. Increased performance is delivered by new engines and propellers. 4 Allison AE 2100 D3s achieve a 15% advantage in fuel efficiency over the previous Hercules engines. More impressively, 72% fewer man-hours are needed to maintain the new engines. The advanced technology composite Dowty R391 propeller is a proven system. It is lighter in weight and has 50% fewer parts. The new engine and propeller combination generates 29% more thrust for the C-130J. Compared to the old Hercules, the C-130J offers an increase of 50% in range on internal fuel, 15% in cruise ceiling, and a gain in speed of 30 knots. Also, the time to climb has been reduced by over 20%, and takeoff distance by over 30%. As you can see, it is an all newly designed cockpit with sophisticated avionics, state-of-the-art displays, and automated crew systems. These fully integrated automated systems reduce the flight crew from 4 to 2 by eliminating the need for a navigator and a flight engineer, a tremendous savings in manpower. The integrated display system features 4 multifunctional liquid crystal displays that replace over 60 instruments. Shown here is the navigation display with the mission flight plan overlaid on an electronic map. Here on the number 2 display, engine operating data and the Flight Ops Smart Advisory, Caution and Warning System, or ACAWS, are presented. The ACAWS system, utilizing audio-visual alarm and clear text digital readouts, advises the pilots of conditions which could adversely affect safety of flight. This smart system's built-in test and diagnostics store data to help ground crews easily identify maintenance problems. Aircraft system status in digital readout format and primary flight data displays are shown here. Two state-of-the-art Head-up displays provide pilots with flight data to include tactical navigation and airdrop information while maintaining their external view. Dual mission computers, like those found in modern fighter aircraft, manage the flow of information between systems and cockpit displays over high-speed data buses. Other cockpit improvements are digital color weather radar and autopilot, and precise worldwide navigation systems, including moving digital map display. Among a vast host of other new features are new electrical and ice protection systems, an advanced auxiliary power unit, improved fuel and environmental controls, built-in self-test and diagnostic features, and a maintenance data recorder to reduce support manpower. For increased survivability, aircraft lighting is compatible for use with night vision goggles for totally blacked out operations, and built-in defensive systems that protect against guided missile threats.
With strong competition now existing in the form of the multinational airlifter, the FLA, European export prospects for the C-130J seem somewhat uncertain.